Hi students, in this video I'll be going through exercise 11C question 7. Alright, so let's read the question. Right, given that y equals to 2x minus 3 times x plus 5 to the power of 5, find the x coordinates of the points where the tangent is perpendicular to the y-axis. Right, so over here we are given this curve, right? Okay, 2x minus 3 times x plus 5 to the power of 5. Right, I don't know how this curve looks like, so I'm just going to simply draw any sketch of this curve. Okay, but this is not the actual shape of the curve. Right, so let's say the curve is, let's say, this. Alright, so they want you to find the x coordinate of the points whereby the tangent to the curve, right, okay, is perpendicular to the y-axis. So if any line is perpendicular to y-axis, do you agree with me that this line is going to be horizontal? Okay, in fact, it's going to be parallel to the x-axis. Right, so basically they want you to if you were to shift this line up and down until it is tangent to the curve, right? Okay, they want you to find the x coordinates of those points. Okay, so if you were to shift this blue line down, it's going to be tangent to the curve at the lowest point over here. Okay, so one example is like that. Okay, so they want you to find the x coordinate of these points. So obviously, if they ask in this way, x coordinates of the points, there's more than one point. Okay, so this graph is going to turn somewhere else or something like this, and there will be another point whereby the tangent is uh, perpendicular to the y-axis. Right. So if a point is if a tangent is perpendicular to the y-axis, what can you say about the gradient of the tangent? Okay, the gradient of tangent is going to be 0, right? Okay, so in other words, to solve this question, what we need to do is we need to find dy dx, which will give us the gradient function. After that, we will equate dy dx to 0, and then we will solve to find those x values, and that will give us the answer, right? Okay, so let's do dy dx. Okay, so quite obviously, due to the nature of this function, whereby it's a product of two different terms, 2x minus 3 and x plus 5 to the power of 5, right? We will need to use the product rule. Okay, so let's say this is u, this is v, right? So if we were to do dy dx, okay, so remember how to perform the product rule is that we will not differentiate the first term, and then we will differentiate the second term. Okay, so the second term we will need to use the chain rule to differentiate. So 5 goes in front. Okay, then power reduced by 1. Okay, if you differentiate inside a bracket, you just get a 1. Okay, then now you plus. Okay, now we will differentiate the u, okay, the first term. If you differentiate 2x plus 3, you just get a 2. And then you have your x plus 5 to the power of 5 over here. Right, let's tidy up a bit first. So 5, 2x minus 3, x plus 5 to the power of 4, plus 2, x plus 5 to the power of 5. Right, so let's take out the common factor. 5 and 2, there's no common factor. So the only common factor will be the x plus 5 to the power of 4, right? Remember, we are going to take the smaller power. Okay, so that's what we're going to take out. Okay, so inside the bracket, for the first half, we'll be left with 5 times 2x minus 3. Okay, for the second half of the product rule, we're left with the 2. And then we've taken out x plus 5 power 4, so there's one more x plus 5 remaining. Right, so let's just simplify inside the brackets. Okay, inside the bracket, we'll have a 10x plus 2x, so you'll get a 12x, alright? Okay, then 5 times minus 3, negative 15. Negative 15 plus 10, so you will get negative 5, right? So we have finished differentiating already. Right, so basically now we're just going to equate dy dx to 0. Okay, but let's write some statement to explain why we are doing so. So if the tangent, okay, of the curve is perpendicular to the y-axis, okay, it is horizontal. Okay, so it is horizontal. Okay, so dy dx will be equals to 0. Okay, so horizontal means in other words, gradient equals to 0. Okay, so dy dx will be 0. So we are now going to equate the dy dx which we found earlier to 0. Okay, then we're going to solve. Right, so either x plus 5 to the power of 4 is 0. So if x plus 5 to the power of 4 is 0, there's only one possibility, which means that x plus 5 has to be 0. Only 0 power 4 can give you 0, right? So x will be negative 5. Right, so this will be one of the answer. Or 12x minus 5 equal to 0. So x will be 5 over 12. Right, so these are the two answers. Right, so I've actually drawn the graph using Desmos, so we can see for ourselves that at x equals to negative 5, this point, the gradient of the tangent will be 0. That means the tangent will be a horizontal line, and then same thing at x equals to 5 over 12. Okay, so if you go down, okay, this graph is actually a very, very, very long graph. If you plot Desmos, you can see the second half of the graph, the y value all the way until negative 10,000 plus. Okay, that's because of this power 5 over here. When you sub any value x plus 5, your power 5 is going to become a very big number, right? That's why the y is so big. Okay, that's why this graph I've cut up the two parts. Okay, because it's impossible to show the full graph within one frame. Okay, so you can see over here at this point. Okay, at this point, negative 5, 0. Remember, one of the answer we got is x equals to negative 5, right? If you were to draw a tangent, which is actually the tangent is now the x-axis. Okay, the gradient of this tangent is going to be 0. Okay, at this point, negative 5. Right? Okay, it's flat. Right, then at the other point, okay, this is a very sharp turning point. Okay, but you can see that I've drawn a blue line there. Okay, at this point, okay, the answer that we got is 5 over 12. So if you compute 5 over 12 in your calculator, you will get this value, okay, 0.4167. Okay, so once again, at this turning point, because it's a turning point, if you were to draw a tangent to the turning point, it's going to be a flat line. Okay, it's going to be perpendicular to the y-axis. So the y-axis is actually over here. Okay, same thing, the x-axis is definitely perpendicular to the y-axis. Alright, so basically this is the significance of the question, and I hope this graph has helped you to visualize the answer better.